right, let's return to Zach and Betsy, our new parents here for a minute. They're like most people. You and I don't have $100,000 to plop into an account today to save for our kids' education. Heck, if we had $100,000 to plop into account today, it would probably be used to put a good chunk towards our house or maybe get a new car. And so what us regular people have to do is we have to save a little bit at a time by setting aside maybe a certain amount of every paycheck. And whenever you do that and you start setting those monies aside, this is what is known as a savings annuity. Now, this is a retirement account. So if you've heard the term 401k or IRA, those are savings annuities, as are lots and lots of different college savings plans. So this is not like a bank account. You're not going to, stick it in your nearest bank and let it earn a piddly amount of interest. This is what you've set aside and you've done some serious planning. So the annuity formula looks like this. It's A is equal to D times the quantity 1 plus R over N, all raised to the NT power minus 1, and your brackets all over R divided by N. Now, there's nothing special about those brackets. Do not enter those as brackets on your calculator. You should still use parentheses on your calculator. It's just when I write them, I use brackets to set that part off a little bit more. It makes it easier for me to see what's going on, okay? So just like with compound interest, the A is the total amount in the account. That does include interest. R is the annual rate, interest rate. T is time of year, or time in years, and N is the number of times your interest is compounded within a year. D is your new one. This is the regular deposit amount. Now notice it says a regular deposit amount. So when do you use this formula? You use the annuity formula when you put money into an account on a regular basis. Okay, so whatever that regular basis is, or a regular schedule, that could mean every month, it could mean every quarter, it could mean every year, every month, that's not going to work very well, every month, every quarter, every year, etc. And then you let it sit there earning interest. So this is, again, an ongoing, regular basis. Okay, very different from the last one where we did it once and we moved on. This is, I'm actively putting money in on an ongoing, regular schedule. By the way, you can set this up so your bank account, just set it up through your bank. You just set aside however much money a month, and then you don't even have to mess with it. Then you don't have to worry about forgetting to set yourself aside some money for retirement. Pay yourself. All right, so let's do an example and see how we can make some money for when we retire. A traditional IRA is a retirement account where the money you put in, you don't pay taxes on now. So you do that before taxes are taken out of your paycheck. But then whenever you take it out of your retirement account when you have retired, at that point the money is taxed. Okay, so there's a benefit now to having that money set aside. So let's say you're 20 years old and you're going to put $50 every month into this IRA, earning 5.5% interest. So the question is, when you retire 40 years from now, how much money will you have in this account? Well, again, our formula, and I'm just going to jot that down so that we've got it all right here in front of us so we can start filling in our values for our variables. Okay, we are going to be putting in $50 each month, so that $50 is our value for D. Our interest rate is 5.5%. Again, write that as a decimal and pay attention that it goes two places in our formula. We're going to be putting our money into our account every single month. So N is 12. And I'm sorry, I forgot to mention up above, if it doesn't say how often you compound, just assume that the compounding of interest happens at the same rate in which you're depositing money. And then we're going to leave that money sit there for 40 years. All right, so again, calculating that exponent first. Okay, so go ahead and take care of that part first. That's going to be 480. And you're going to want to enter this exactly as it is on the paper. So you're going to want 50, parenthesis, parenthesis, 1 plus 0.055 divided by 12, parenthesis, raised to the 480 power, end your parenthesis, divided by, and then be very careful about this. You want another set of parentheses around that denominator so that you divide by the entire fraction. Otherwise, your calculator will divide by the 0.055 and then multiply the entire thing by 12. That is not what you want. So please insert another set of parentheses. Okay. When you get done, and this is how you'll know if you did it correctly on your calculator, you should have $87,051.98 in your retirement account whenever you retire 40 years from now. Now, how much of that is interest? So interest is found by taking the total in your account and subtracting what you put in. And anything else is going to be interest. So this isn't a formula as much as it is common sense. I have a total amount in the account. That's more than what I put in because I earned interest. So to find out how much is interest, just subtract. So the total in the account is your $87,051.98. And what you put in was $50 times 12 months a year for 40 years. That represents the amount of money you actually put into that account. Whenever you go ahead and calculate that, your 50 times 12 times 40, notice that you only put in $24,000. That's what came out of your pocket. The rest of that, $63,051, and 98 cents is how much you earned in interest. So look at how much your money grew by simply setting aside $50 per month.